So for this topic, which is transformations, I'm going to use the absolute value function for the example, even though we can use any of the other ones that we've gone over. So I've introduced linear, I've introduced square root, quadratic, and the fourth one was absolute value. So that was on the Ed puzzle. So the equation for absolute value, this is the one that we've worked with the most because we've done solving equations and inequalities with absolute value. And then f of x is the same thing as y is equal to. Just writing both of these, they're the same thing. And on the Ed puzzle video, I told y'all a good way of remembering the shape of the absolute value graph is the V in the word value. You always start at the origin, so you start in the middle. And then just draw a V. Make sure that you have your two arrows at the ends. And we're actually going to divide these notes into two parts. So part one is going to be focused on two different things, or really three. You'll see whenever we get to the right side of this page. But down here, we're only going to do 6 of these. So we're going to start with graphing number 1 on the calculator, decimals as well. So all I'm going to do is plug in number 1. Press enter. So this is our graph. You're always going to compare your parent function, which is the orange one, to whatever you get on here, at least for those things that we're going to do right now. So from the orange one to the blue one on the calculator, it moves 2 units to the left. So that's a transformation. And then I'm actually going to give you the rules on the other side. But for right now, we're just focusing on this. Whenever you guys use your calculator, you always want to press tab. Don't type another function. You don't want to type number 2 right away, just because you don't want to be having more than one graph at the same time. You go up, which takes you to the previous one, and then just change whatever you have to change to make it number 2. So I'm going to change the plus to a minus, press enter. So now we have this graph. We're still comparing it starting with the parent function, which is the orange one. So from the orange one to the blue one, what it did now is go to the right twice. I'm going to do the same thing with number 3 and number 4. So now it went up twice. You can probably guess what it's going to do for number 4. I'm still going to show it on here. This one goes down 2 units. We're going to skip 5 and 6 for part 1. We'll get into that next class period. So now I'm going to do number 7. So here you can see from the orange to the blue one that it flips upside down. So anytime that this is flipping, it's actually called a reflection. And we will be talking about 2 reflections. If I was to draw this one here, and I'll do it in black pen. So from the orange to the black one, it's flipping across the x-axis. It's upside down. So this one I'm going to write reflection over the x-axis. So many times you can rely on your calculator if you forget what the plus or the minuses stand for. But then you're going to get questions or equations like number 8, where sometimes it's a little bit hard to see. So you have to rely on the equation. So whenever I graph this one, if I compare it to the orange one, it looks the same. So it looks like nothing happened here, but the equation, since this is not the original, there's a negative here. That means that something is happening. And what's actually happening, the way of thinking about this is if you take this side, just focus on this side and you reflect it across the y. So if you reflect it from here to this side, then you end up with this section. Same thing if you start with this side and you reflect it across the y. So if you take here and bring it to this side, you end up with this. So in the end, you end up with the same graph, but you are doing a reflection. So something is happening. And you get that again from the equation. So that is going to be the reflection over the y-axis. So I'm going to give you the rules here on the side. And on the top, I'm going to write this. You do not have to memorize this, but just know that that A, that C, the H, the K, they all do different things to your graph. So far, we're going to really focus on the H and the K for today. And then we'll talk more about the A and C next class period. So for your translations, so if we look at this right here, that is being doing addition or subtraction on the inside of your parent function. So that's going to look like these two, like number 1 and number 2, because we have a plus and a minus on the inside. So both of these are always going to be horizontal shifts. And if you have a plus, it's going to go like number 1, it's going to go to the left. If you have minus a number, which we did on number 2, it's going to go to the right. The next two, we're adding and subtracting a number, but now we're doing it to the outside. Like number 3 and number 4. If you see plus a number, so these are going to be, before I get into that, these are the vertical shifts. And like I was saying, if you have plus a number on the outside, that one's like number 3, so it's going to go up. If you have minus, like number 4, it's going to go down. We're skipping the dilations for today. We'll go into that next class period. And then we have our 2 reflections. So if the very first thing you see is a negative in front on the outside of your parent function, and it's on the very, very front, this is always going to be a reflection over the x-axis, like on number 7. So it was in the front and it's on the outside. Then if you have it on the inside of your parent function and it's still in front of the x, like right here, that one's going to be your reflection over the y-axis. So I'm on the back of the notes where I'm going to give you a quick little setup that we're going to be using today and next time. And I'm going to give you 3 of the 4 parent functions that we've talked about is what are the ones that we're still going to work with. So we're not really going to be doing linear. We're going to do the other 3. And I'm going to start off with the one that you've seen the most. And this one is absolute value. So I'm going to write the names on the side. Quadratic. One is going to be square root. So notice how the absolute value, the parentheses with the squared and the square root, I did it in a different color just to show how you have stuff on the inside of that. and it's the same stuff on all three of them. And then you have stuff on the outside of them, which would be and K. Both of those are on the outside. So this is going to bring us into the 2 bullet points that I want for you guys to write. And it's going to make so much more sense whenever we get into the other half of transformations. But for right now, it's so the term that I'm about to use, so the stuff in green, the absolute value, the parentheses, the square root, I'm going to call them our little houses. And you're going to see why I'm even using that word. It sounds a little bit silly, but the reason why I'm using that word is the house. It's horizontal. That's why I'm using the word house, because it starts with an H and horizontal starts with an H. And this is going to be lie. And you'll see what that even means when we start doing a few problems. The second thing is going to be pretty much the opposite of this. So everything on the outside. If it's not horizontal, then it's going to be vertical. So everything is vertical, and then the opposite of a lie is going to be the truth. So this is so the last thing I'm going to label for today up here is going to be everything after the X. So it's going to be like that. So no matter if it's on the inside or on the outside, as long as it comes after the X, these are going to be our shifts. And a shift means that you're moving it either up, down, left, or right. So that's going to get us started into our 4 practice problems. So the first 2 are just going to be to list the transformations. So that's going to be number 1. And the way that I want for you guys to do it eventually, because you're eventually going to start doing these without notes, is you want to compare this equation, this function, to the parent function. So the parent function of the square root is the most basic one, which is just the square root of x. And it does help if you circle everything that's different between the green one to the orange one. So what would be different here would be the negative sign, and then the minus 3. So we circled 2 things, which means you should be listing 2 different transformations that are going on. So I'm going to start with the negative sign. The negative is in front of the x on the inside. Go back and look here. On the inside, in front of the x, is your reflection over the y-axis. So that is what I'm going to write for this one. Then anytime you have a number, whether it's positive or negative here, I want for y'all to start by listing if it's vertical or horizontal. So remember, only numbers inside the house are horizontal. Everything else outside is vertical. So minus 3 is outside, which means it's vertical. And then it also comes after the x. So vertical is like this, like my pen. So that means if you're shifting something vertically, you're either going up or down. Those are your only 2 options. And you have to remember that vertical is the truth. So you go with whatever the sign says. So if the sign is a minus 3, that means that you're going to go downwards. That's going to be the truth. So that's going to be down 3. And then we'll do one more that's going to be So this one's number 2, so it's going to be the same thing. You want to write your parent function first. That's my parent function, the absolute value of x, and we circle everything that's going to be different. So this one's going to be the negative, -1, and the +2. So I'm going to start with the negative. The negative is on the outside of your parent function in the front, like this one. So that's going to be reflection over the x-axis. And then those two, since both of them are numbers, I'm going to go ahead and do them at the same time. You always want to start off by labeling, is it vertical or horizontal? So the only one inside the house is the -1. So that's the one that's horizontal. Vertical. And then both of these numbers, the -1 and the +2, come after the x. So both of these are. So I'm going to start with the +2. Vertical shift is like this, vertical like this. So your options are either up or down, and vertical is the truth. So if it's a +2, that should make you want to go up. That's going to be up 2. For the horizontal, now we're looking at this direction. So your options are left or right. But you have to remember that horizontal is a lie. So you always want to think about it as what would you originally want to do, and then you do the opposite of that. So for example, the -1 should make you want to go to the left. But since it's telling you a lie, you do the opposite. So you're really going to be going to the right side. So that is going to be right 1 unit. For number 3, we are looking for what is the equation of the graph that is given, so the green one. Anytime you're trying to come up with an equation, you want to compare it to the parent function. So I'm going to go ahead and draw the parent function, which starts in the middle, like this. And the way you want to do this is, if you go from the black graph to the green one, you want to write down in words first how you go from one to the other. So I'm going to use this point right here. That's why I mark it. But I'm going to go from here. And if I want to get to the green one, that means that I have to go to the left twice and then 1 down. So I'm going to write that down. So then I'm going to use that information to come up with an equation. Since this is a V, that means that this is absolute value. You have to always use your actual equations for this. So our absolute value is like this. I left some space because we are going to put a number in there. Sometimes you might not, it just depends. And then you have to figure out what's vertical, what's horizontal, and where do these numbers go. So starting with, I'm going to start with down 1. So down, remember up or down is like this, and that's vertical. And down on the outside. It goes somewhere right there. And this is also going to be the truth. So if you see down, then that should be a minus sign. We have -1. So this is horizontal. Which means it goes inside of the house. So that's going to go right there. It goes after the x. And then this is going to be 5. So even if you're going from words to equations, it still works the same way. You think of what is left to make you want to put. So left should make you want to put a minus sign. But since it's the opposite, we're really going to put a plus. So that would be your equation. You can always graph that if you want to double check, and it should match the green graph that we started with. Okay, and then finally, number 4, it's going to be kind of similar. So here we have the graph of g of x, the green one, was obtained by translating f of x. So that means that we started with f of x and we went to the green one. So which equation can be used to describe this one in terms of f of x? So here, on this one, we started with the parent function because we only had the green one to go from. So for number 4, we know our beginning is the orange one, and we're trying to get to the green one. So it also helps to write it out in words. How do you go from the orange one so that it can look like the green one? So there's actually 3 things happening here. The first one would be that the obvious one would be that this one is a U. This one is an upside down U, which means this is a reflection over the x-axis. So anytime it's upside down, there is a reflection over x. So if we look at our transformations, reflection over the x is seen by a negative in the front. So the answer choices, there's only 2 that have a negative, which is these 2. So it wouldn't be A or B. And then we have 2 more things that are going on. So from this point to get to the other one, we went 1, 2, 3 to the right, 1, 3 down. So I'm going to start with down, vertical. It's on the outside, and it is the truth. So if it is the truth, down should be a minus sign. Both of these have minuses and they're both on the outside, so we can eliminate anything from this. It all depends on 4 units to the right. So this is horizontal on the side of the house, of the H, and this is the line. So if you're going to the right, you originally should be thinking of a plus sign because we're going in that direction. But since it's going to be a lie, we do the opposite. So instead of a plus, we're going to do a minus. So the final answer would be D.